Welcome back. For those who who don't know me, because you're coming into this for the first time because it's modular function and that's what you want to go over, or for those who got fed up of all my previous lessons and seeing the same face and the same examples and things like that, you got bored and you've gone away and you come back, you might have forgotten who I am. My name is Sosale Mohana. I am a maths teacher with a considerable experience of teaching A-level maths, and these lessons are to help students like you revise various aspects of A-level pure mathematics. Welcome back then. So we were doing algebra, so I will continue with algebra. I think it was topic 3, and then we finished exponential functions, logarithmic functions, logs. I didn't do any indices or surds because I consider it to be very cheap. You're all clever people, man, so I don't have to do it. So today I want to concentrate on modulus functions. Modulus functions. First I'll give you definitions and then I'll take some examples. F of x equal to mod x is defined like this. Mod x equal to x for x greater than or equal to 0 minus x for x less than 0. Meaning f of 2 is 2. F of 0 is 0. F of minus 1 is minus 1, which is plus 1. Meaning, modulus means absolute value of f of x. X can be negative, but modulus of x is positive. Remember, modulus is this, to give a connotation in vectors or to give a connotation in mechanics. Modulus is nothing but the magnitude, or even in complex numbers. So therefore, and how does the graph look like? The graph looks like this. For any value of x, 0 or greater, it's like that. If the line y equal to x. If it is minus 1, y equal to x gives you minus 1. But this is plus 1. Y equal to x gives you minus 2. So plus 2. In other words, it is the reflection of the portion of y equal to x below the x-axis in x-axis for negative values of x. That's how you define a modulus function. Geometrically, right? Geometrically, the graph of y equal to mod x for negative, for positive values of x is the same as the graph of y equal to x. But for negative values of x, it is a reflection of y equal to x in the x-axis or the line y equal to 0. Then how do I sketch, let's say y equal to mod 2x minus 3. The easiest way to do will be start with find the critical value. 2x minus 3 is 0, x equal to 3 over 2. Okay. So, this is for, I am now, look, clever people know how to do it. It's for people like me who need a lot of thinking. So, x is 3 over 2. That's y. Take two values less than 3 over 2, 1 and 0. Take two values more than 3 over 2, 2 and 3. Find the values of y. When x is 0, y is modulus of minus 3, which is 3. When x is 1, 2 minus 3 is minus 1. Y is modulus of minus 1, which is 1. There it is 0. There it is 2 to the 4. 4 minus 3 is 1. And then 3. Plot those points. So I've got 3 over 2. And then that's 2. That's 1. That is 0. That's 3. So at the 2, it is 1. At 3, it is 3. At 1, it is 1. At 0, it is 3. So that's the graph. That would be the graph of y equal to mod. In other words, in general, whenever you got mod of ax plus b, put ax plus b equal to 0, get the value of x, and then take two values. You can take 100 values to the left, and 100 values to the left. You can spend the whole 1 hour, what's that, 90 minutes or 80 minutes of your exam, or 1 hour 40 minutes of your exam taking values and plotting a beautiful graph. You'll just get the 2 marks and that's it. It's only a sketch, so don't spend too much time. So therefore, plot the points. Generally, mod of 2x minus 3 is a V-shaped graph. It could be mod of 3 minus 2x as well. But then, let us see what if it is. So that's how you do it. So to sketch the graph of y equal to modulus ax plus b, you put ax plus b equal to 0, find the value of x, take 2 or 3 values to the left of the root, 2 or 3 values to the right of the root or the critical value, and then join them, and remember it's a V or an inverted V graph depending upon the question. For example, generally it is a V graph. When will it be inverted V? We will see in a minute. Suppose I wanted y equal to 3 minus 2 mod x minus 1. Aha! 2 ways of doing it. One is sketch the graph of mod x minus 1. Multiply by 2, it's outside. So it's something like, suppose I call f of x equal to modulus of x minus 1. This will be 3 minus 2 f of x. You know, I always love to think in terms of transformation so that you understand. F of x is being multiplied by 2. And 2 is outside the bracket of f of x. So that means the value is the values of y. So the graph of y equal to mod x minus 1, the y values will be multiplied by 2 at the stretch parallel to y axis. Then minus, y becomes minus y reflected in x axis. Then 3, you are adding a 3, after reflecting, take it up by 3 units. But that's too complicated to think, isn't it? There is an easier way. So therefore, plot points. That's one way of doing it. What is x minus 1 equal to 0 gives you x equal to 1, right? Let's see if whatever system I taught you before would work. I'll take one extra point because I'm going to get, okay, this is 1. 0, minus 1, minus 2. Then 2, 3, 4. I'm taking 3 values instead of 2 values. Let's find y. When x is minus 2 minus 1 is minus 3. Right? Minus 2 minus 1 is minus 3. And then minus 3 times 2, minus 3 becomes 3 because of modulus. 3 times 2 is 6. 3 minus 6 is minus 3. When you take minus 1 and minus 1 is minus 2. Modulus of minus 2 is 2. 2 times minus 2 is minus 4. 3 minus 4 is minus 1. 0 minus 1 is minus 1. Modulus of minus 1 is 1. 1 times minus 2 is minus 2. 3 minus 2 is 1. And when you put, that will be 3. Because that becomes 0. At 2, 2 minus 1 is 1. 3 minus 2 is 1. At 3, 3 minus 1 is 2. 3 minus 4 is minus 1. 4 minus 1 is 3. 3 minus 6 is minus 1. What do you notice? The highest point is when that becomes 0. X equal to 1, y equal to 3. So, at 1, 3, let's say 1, 2, 3, minus 1, minus 2, 1, 2, 3, 4, minus 1, minus 2, minus 3. Rough sketches, of course. As you can see, my divisions are not as good as they should be. 1, 3. 1, 3. I go back. 0, 1. -1, -1. -2, -3. You got that graph? And then 2, 1. And then 3, -1. And then 4, -3. See that graph? That would be the graph. So the best way to draw the graph, even though of course I talk to you about transformations. Sometimes, depending upon the kind of students I have, I teach using transformations. But in an exam, they don't bother which way you do as long as you get your graph right. So I would rather stick to the simple tables which you are very familiar with in your GCSE and then do it. Instead of drawing instead of doing transformations. So whatever is the modulus, equate it to 0. Then take 2 or 3 values to the left, 2 or 3 values to the right, plot them, join them by straight lines, because I'm only talking of ax plus b. Straight lines, and then either the graph will be, remember Churchill, victory sign, or sometimes the other one. When somebody you don't say, you boo people, yeah. So you're booing this graph. This graph you're booing because it's going positive, it's going negative. You said modulus is always positive. Here I'm getting negative values. Please remember that modulus is still positive because it is being multiplied by a minus sign. After a certain stage, it's going to become negative. So minus mod x will always be negative. Mod x will always be positive. Alright? So in the next lesson, I'm going to solve some modulus equations and also talk of 2 more transformations which the examiners like. How to sketch modulus of f of x and how to sketch f of modulus of x. I'll do those things in the next lesson. Thank you very much. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.